azeotropes. Azeotropes, this is a binary solution having constant boiling point like that of pure solvent. Pure solvent has a constant boiling point, like ethanol has a boiling point 351.5 Kelvin, water has a boiling point 373 Kelvin, nitric acid has a boiling point 359 Kelvin. So pure solvent has a definite boiling point. But if you take a solution, then it has not a constant boiling point. It has a range of boiling temperature. But azeotropes, although a binary mixture, but it has a definite boiling point like that of a pure solvent. So if the mixture or if the binary solution has a definite boiling point like that of a pure solvent, then what happens? Then the composition in liquid phase is same with the composition in vapor phase. Composition means you can say mole fraction. Mole fraction of the two components in a liquid phase is same with the mole fraction of the two components in vapor phase. That is, if the mole fraction of the two components in liquid phase are 0.6 and 0.4, then in the vapor phase also the mole fractions are also same 0.6 and 0.4. So azeotropes are constant boiling mixture, that is, it has a constant boiling point like that of a pure solvent, and as the boiling point is constant, so the compositions of the components are same both in the liquid phase as well as in vapor phase. And as the boiling points are the boiling point is constant, so the azeotropes cannot be separated by fractional distillation process, because in fractional distillation process the two components should differ in their boiling point, that is, the two components should boil at different intervals. But as azeotropes boil at a definite temperature, so azeotropes or azeotropic mixture cannot be separated by fractional distillation process. Okay, so what are the 3 points regarding azeotropes? Azeotropes is a constant boiling mixture. In azeotropes, the composition in liquid phase is the same with the composition in vapor phase, and in azeotropic mixture the components cannot be separated by fractional distillation process. Azeotropes is of two types: azeotropes minimum boiling azeotropes, another one maximum boiling azeotropes. So minimum boiling azeotropes, maximum boiling azeotropes. The solution which shows positive deviation acts as minimum boiling azeotropes. The solution which shows negative deviation acts as maximum boiling azeotropes. So in positive deviation there is 95% ethanol and water. 95% ethanol and water acts as minimum boiling azeotropes. 95% ethanol and water. In 95% ethanol and water, the boiling point of the mixture at this composition is less than the boiling point of the individual components. For why it is called minimum boiling azeotropes. As I said before, water has boiling point 373 Kelvin, ethanol has boiling point 351.5 Kelvin, but at this composition the boiling point is 351.15 Kelvin. This boiling point of the mixture is less than the boiling point of the pure components, both ethanol and water. For why this acts as minimum boiling azeotropes, where the boiling point of the binary mixture is less than the boiling point of the individual components. Another one is maximum boiling azeotrope. Maximum boiling azeotrope means the solution which shows negative deviation acts as maximum boiling azeotrope. Example: 68% nitric acid and water. 68% nitric acid and water acts as maximum boiling azeotrope. As I said before, nitric acid has boiling point 359 Kelvin. Water has boiling point 373 Kelvin. But at this composition, that is 68% nitric acid and 32% water, this composition, this mixture has a boiling point 393.5 Kelvin. That is, the boiling point of this azeotropic mixture is greater or its maximum than the boiling point of the individual components, that is nitric acid and water. For why? This is called maximum boiling azeotropes. Okay, so this is all about your part 2 of a solution, where we cover Henry's law, Raoult's law, and a ideal solution, non-ideal solution, along with azeotropes. Regarding this concept, you can solve the problems or questions from the NCERT exercise. So from this part 2, you can solve the questions from 2.10 to 2.14 and 2.34 to 2.39, except question number 2.